Now we'll subtract second equation from the first equation. So if we do 1 minus 2, you can clearly see that these two terms will cancel. F dash x and f double dash x, these two will cancel. So basically the equation that you will get is fx minus f triple dash x, and this will be x raised to 5 minus 5x raised to 4 plus 64. And now all we have to do is find this f triple dash x, and then we can easily get our function fx. Welcome to our YouTube channel ARYA Mathematics. In this video, we are going to discuss a problem from JEE Main 2022. We have a polynomial function satisfying this equation, and we have to find the value of limit extending to 1 fx divided by x minus 1. Now, there are at least two different methods of solving this problem. One will be the general method. So here, remember that fx is a polynomial function, and this equation is given to us, right? So using this equation, basically we need to find f of x, and once we get fx, then we need to calculate this limit. Now remember, when we differentiate a polynomial of degree n, then we get a polynomial of degree n minus 1, right? So if fx is a polynomial function of degree n, then this left hand side will be of nth degree, because f dash x and f double dash x will be a polynomial of degree less than the degree of fx. And on right hand side we have x raised to 5. So therefore fx must be a polynomial function of degree 5. Right, for f of x degree n, this must be 5. So the general method of solving this problem will be that take a general fifth degree polynomial. So that means take fx as ax raised to 5 plus bx raised to 4 plus c into x cube plus dx square plus ex plus f. Let us take this polynomial, and now find f dash x and f double dash x, and then substitute in this equation. Let us call this 1. So substitute in equation 1, and by equating the coefficient of same power of x from left hand and right hand side, we'll get different equations. So using those equations, find the value of a, b, and in this manner find the value of f, right? A, b, c, d, all of those variables. And once you get these values, then you will get the function, right? So find these variables, from there calculate fx, and then once fx is known, then we can find limit extending to 1 f of x divided by x minus 1. But as you can see that because there are number of variables, this method will take some significant calculation. So in this video, I'll explain another much easier method of solving this problem, where in 2 to 3 lines you can directly get the function fx, right? You do not have to solve these equations and find a, b, c, d, these unknowns. Directly we can get fx. So see here, the given equation is f of x plus f dash x plus second derivative of fx, and this is x raised to 5 plus 64. Now call this equation 1, right? This is the given equation. Now here what we'll do is we'll differentiate this equation both sides with respect to x. So that means we'll get f dash x, then this will become second derivative, and then this will be f triple dash x, and the right hand side will be 5x raised to 4. Call this equation 2. And now we'll subtract second equation from the first equation. So if we do 1 minus 2, you can clearly see that these two terms will cancel. F dash x and f double dash x, these two will cancel. So basically the equation that you will get is fx minus f triple dash x, and this will be x raised to 5 minus 5x raised to 4 plus 64. And now all we have to do is find this f triple dash x, and then we can easily get our function fx. So now the next step will be differentiate this third equation 3 times so that we can get f triple dash x, right? So now we are going to differentiate equation 3 with respect to x 3 times. So fx, this will become f triple dash x, and notice that fx is a fifth degree polynomial, so the sixth order derivative of fx will become 0, right? And on right hand side, the third order derivative of x raised to 5. So 5 into 4 into 3, that will be 60 x square minus, and then 4 into 3 into 2. So 24 into 5, 120 x. So this is f triple dash x. And now substitute that value in equation 3. So then your fx will become x raised to 5. And this term we can take on right hand side. So x raised to 5 minus 5x raised to 4 plus 60x square minus 120x plus 64. So finally this is our fx. Right, if you solve by first method, then also you will get the same expression for fx. But as you can see that this is much easier method compared to the first one. And now we have to find that limit x tending to 1, fx divided by x minus 1. So as you can see that at 1 the denominator will be 0 and the numerator will be also 0, right? 60 plus 64 plus 1, so 125 minus 125, that will be 0. So therefore we can apply L'Hopital's rule. Using L'Hopital's rule, the limit will be f dash 1 and f dash 1 will be 5 minus 5 into 420 plus 120 minus 120. These two will cancel. So 5 minus 20, that is nothing but minus 15, right? So the correct answer for this problem will be minus 15, and hence option A is the right answer.